Any questions on conics? So we got our test tomorrow. You got a lot of review sheets. Anybody got a question or anything? You can run through some stuff. I can tell you, if you are not taking this seriously at this point, I'm not saying it's too late, but when really smart, talented students are coming up and asking questions with fallacies, it makes me really worry about the ones that struggle. But there's a lot of memorization on this. There really is. I mean, at the end of the day, it kind of might all make sense, but you're going to have to discipline, maybe get note cards, whatever, do whatever it takes. But there's a lot of ways to lose a lot of points. But on the flip side, if you're a good memorizer, there's a lot of ways to get a lot of points just through memorization. What is A? What is B? What is the length of lattice rectangle? What is the distance to the vertices? What are the vertices? What are the foci? What is the distance to the foci? I mean, all of those little values are like 3 points, 3 points, 3 points, 3 points, 3 points, 3 points, and they add up. But then you're also going to have to put stuff together, like me give you just enough information to make a conic out of it, and you got to get there. So I will test it all, and there will be people in here that will do really, really well. And hopefully there won't be anybody who gets hammered, but if you take it lightly, if you know how to do all the problems that you've just seen on these reviews and you feel really comfortable with them, I think you'll be in really good shape. Yeah.
Well, I think I want to use one.
Can you give me just a page number?
On the normal one, it's 35.
35? What number?
It's not 13, but it's like the last two.
Okay, so on number 13, the first one looks like an ellipse, but it's a 0, so it's a degenerate ellipse. But if the question, so if I said, what is this? You could answer degenerate ellipse, or you could say it's a point, because degenerate ellipses are points. Now this one, it kind of looks like an ellipse, but it's a negative number. So if I did divide through by a -1, which is what you do with ellipses, you want that value to be a positive one, that would make both of these negative. Do we have a conic where they're both negative? No, so this is not a conic. And by the way, there's no way to square something and then to square something else, which guarantees that it's either positive or maybe 0. There's no way to do that and end up with a negative number. I can't square two things and add them and get a negative. It's impossible. So I would just say D and E here, but don't say D and E here. Because look, on this one, again, it looks like a hyperbola, but it's not -1. So if I multiply through by a negative to make it +1, great, but now it's just out of order. So these actually do still exist. That's a hyperbola. So the last one's a hyperbola, the middle one's a D and E, and the first one is a degenerate ellipse, which is a point. Yep.
This kind of is a question, but it kind of goes with numbers 10, 11, 34. But so how do you tell, it does determine the relationship between A, B, and C, but like, how do I tell whether it's A squared minus B squared, C squared, or A squared?
Okay, so the trick I told you for both of these was to do this. So the trick I said on these, rather than memorize, like if in your notes or in a book, over here you will see hyperbolas are always this. C squared is A squared plus B squared. Ellipses are always A squared equals B squared plus C squared. But that is hard to remember for some people. So what I did is I said, well, you could do this. What you can do is say, for both of them, C squared equals A squared blank B squared. And if it's minus, put a plus. And if it's plus, put a minus. So for this one, I'm going to go, the relationship is C squared equals A squared plus B squared. And for this one, I'm going to say C squared equals A squared minus A squared minus B squared. And that way I have a formula that feels the same. And sure enough, look, if I solve for A squared here, I get A squared equals B squared plus C squared, which is your formula for an ellipse. But it just makes it where it's kind of a one formula that works for both, and then you don't have to memorize whatever. But just remember, if you remember that, and then whatever the sign is, change it for the middle, and then use it. But again, you got to do the opposite. So if that's a minus, you use a plus for a hyperbola. If that's a plus, you use a minus for an ellipse. So for whatever that's worth, I don't care how you memorize them, but that's one way that my students have liked in the past. If you like it, great. If you just have it memorized, that's great too. What else? Anybody have anything? I mean, you're welcome to just do your thing if that's the way you roll. But if you have questions, I would certainly love to straighten you out. Yes.
Okay, so like the transit and conjugate, I don't know which one's like the like longer one.
It doesn't work that way. That's why they don't call it major minor. So the reason, and she asked a great question. She says on a hyperbola, is the transverse or the conjugate, which one's the biggest? Well, if it was always that case, they would have just called it major minor. See, it just depends on which way the graph is going. But I can tell you this, the transverse is always 2A. But just sometimes A is smaller. Like right here, which one of these is A? On a hyperbola. The first one. So here A is 2, B is 5. A is smaller. So your box right here is going to only be stretched up 2, but because A is 2, that's the distance to the vertices. A shows distance to the vertices, and double A, 2A, is the length of the transverse. It just doesn't happen to be the biggest one on this one. Over here, what's A? Root 12. Why? Or 2 root 3. Why? Because it's bigger. Ellipses, it's bigger. And here, it's a major. Major is 2A. But sometimes the conjugate is the biggest, sometimes the transverse is the biggest. On hyperbolas, it has nothing to do with bigger or smaller. But I will say this, the transverse, like we said, transcontinental railroad connects 2 places on the continent or whatever. So point is, it connects the vertices. It's kind of like a hyperbola is not 2 parabolas going in the opposite direction, but it kind of looks that way, you know? So right there, it's kind of like vertex, vertex. That is the transverse. And that's A there and A there. On an ellipse, and if it was going up and down, it would be A there and A there to the vertices. On an ellipse, whether it's going left or right or up and down, the A measures to the vertices also, but the vertices are at the endpoints of the long section, endpoints of the major. And on an ellipse, on a hyperbola, they're at the endpoints of the transverse. Yeah.
Which one is the one where you take the first one?
Hyperbola.
Hyperbola, you
Always take the first one, assuming that it's in the right form. If it's not in the right form, all bets are off. Yeah. Yes. So I like to put a few of these problems on there to see if you can put it all together. So you're going to have to be able to think. I mean, there are going to be plenty of questions where I just have you spit out answers, blah, 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 like I did on the parabola test where you had all kinds of little facts. But you're going to have to put it together. So I like drawing a picture on these to get a visual. All right. And if you know what your graph looks like, you'll be in good shape. So this says hyperbola. So I immediately know it's going to have a minus in between the squares. But I also am going to sketch a quick little graph here at 5, -9. So let's just say that's 5 down 9. And then at 5, -1, these are my foci. So focus there, focus there. What does that tell me right now? The what? The center is in the middle, so it tells me the center. But what else does it tell me? Going up and down and on. That's important because that tells me which one comes first on a hyperbola. It doesn't matter on an ellipse. Put them whichever way you want, right? But on a hyperbola, the direction is shown by the first variable. So y squared, then x squared minus, I'm immediately right here, just knowing that this thing is stretched up and down. All right, now the center has to be in the middle of those two, right? Whether they're vertices or whether they're foci, it doesn't matter. It's dead in the middle. So if I'm here at -1 and I'm there at -9, what's the average of those two? -5. So I'm at 5, -5. So if my center is 5, -5, I can go x -5, y +5. Now you're probably at the halfway point in your credit at this point. You knew it was an ellipse, you knew what came first, and you entered the center. Now, the other 2 points you're going to have to earn. So what do I know? They told me, what other information did they give me? The difference of focal radii is 6. What is the sum or the difference of focal radii always equal to? 2a. So that tells me if 2a is 6, then a is 3. And what do I know about a on hyperbolas? It comes first. So boom, 9 goes right here. Now I'm almost there. You go ahead. Sorry? Where are they? On a hyperbola, say it's going this way, this one's not going this way. It's focus to any point, focus to any point. Those would be focal radii. And the difference of those two is always 6. So this minus this is 6. Big one minus small one, 6. Even big one minus small one, 6. It's always equal to 6. It's kind of hard to turn the string or whatever. Like, I don't have a fun little thing with string to show you, but I think we measured one in class and showed that, it is pretty close. And then the last thing I need is my B value. Well, I know A. What do I need to know to find B then? I probably need C, don't I? Do I know C? A is always the distance to what? We said this already today. It's the length of the major. It's the length of the 2A is the length of the major. 2A is the length of the transverse. 2A is the sum or the difference of focal radii. But what does A measure? Not to the focus, to the vertices. From the center to each vertex. That's A. Okay, so I happen to know that. I just didn't need it. What is the center to each focus? C. So this tells me that that length right there is little c. And it's clearly 4, right? So I know C is 4. And since I know A is 3 and C is 4, I've got 2 of the 3 variables. What ABC relationship do you use with hyperbolas? Remember the trick? C squared equals A squared, B squared. Change the sign. So I'm going to plug the C in there, 16. I'm going to plug the A in there. A is 3, so 3 squared is 9. And I can just subtract the 9 to get 7. And you don't have to square root it, because what do I want? I really don't want B. I want what? B squared. I already got B squared. So you got to put all that together on a problem like that. So yes, you can get a lot of points knowing facts. But at some point, you're going to have to be able to think through that. So here, A would be 3, B would be root 7, C would be 4. Now I'm asking you for the equations of the asymptotes. So what did I say to do on asymptotes? You can try to graph it if you want, but I hate doing that. You got 2 options. I'm going to do the first one I showed you. You know both asymptotes go through the center. So why not use the center for your point? Y minus the negative 5 equals plus or minus, the slopes go both ways, something. I don't know what it is yet. I'm going to leave that blank. And then x minus the x coordinate. But if you really look, all I did was take the y plus 5 and the x minus 5 and write it there and there. Now, what would I have risen on my box? Like if I was sketching the box out, what would I be rising? The square root of that, 3. Right? That's what I do. I rise whatever's under the y. So when I'm sketching out my box, I would have risen 3. And what would I be running? Root 7? And isn't rise over run my slope? Do not memorize that your slope is A over B. Because it might not be. If the x is there and the y is there, I'm sorry, it's the number under the y. So if the y's are over here, that would be your B value. So don't memorize that it's A over B or B over A. Just say, hey, for my box, I would be rising 3 and running 7, and that would have been the edges of my box, right? So that rise 3, run root 7, that gives me my slope that I need on this thing. But plus or minus goes both ways. Now there's one other way to do it that I do not encourage you to do. What is a degenerate a hyperbola? The asymptotes. So if I said, what are the equations of the asymptotes? What could you do? You could change that to a 0. That technically, those are the equations of the asymptotes because that's a degenerate hyperbola. But you know what the question I normally ask is? What are the equations of the asymptotes in point slope form? That's not point slope form. So for you to get that to point slope form, here's what you have to do. You have to take this negative thing and move it to the other side. When you do that, you get this. Then you have to solve for y by multiplying by a 9. And then what? Square rooting both sides. But what happens when you square root both sides? Y plus 5 equals plus or minus 3 over root 7. And that square root makes the square go away, x minus 5. And isn't that my equation of the line? And if you're about to ask, do I rationalize the slope? Yes. Always rationalize fractions in algebra 2 and pre-calc. Nobody cares in calculus. But in math team land, we care because the tests we take care of. Right? But in calculus, honestly, nobody cares. Yes?
Are the foci always on the major axis?
The foci are always on the major or the transverse. The major and the transverse are where all the foci, the vertices, all that lie. Sometimes it's this way, sometimes it's this way. Yes. Anybody else? Nobody? All right. If you change your mind, know where to find. Got a question?
No, no, sorry.